A very happy and a pleasant good morning to you all children. On this very cool morning, let me take the pleasure of taking up a new lesson and introducing the new lesson to you. The name of the lesson is Force and Laws of Motion. So this is a very lengthy lesson, and the concepts about this lesson are much needed for a better understanding when you take up physics in your higher classes. What I mean to tell you is this is the basic of the Newton's laws of motion. So this lesson is a very interesting lesson, and also it is the knowledgeful lesson in order to know more about forces and motion. So we quite frequently experience many things around us, and we don't know what is the scientific reason behind them. For example, we play the game of tug of war. In some case, a team wins. In some case, no team is supposed to win. And what is the scientific behind this? And more than that, we can quote many number of examples in our day-to-day life. We dust a carpet by hanging it and beating it. The dust gets fallen off. When we are sitting in the bus, when the bus suddenly starts, we tend to move backward. The passengers standing on the bus, when the bus is being suddenly stopped, the standing passengers tend to move in the forward direction. So these are quite a few examples which I give to you, and all these examples come under one particular law, Newton's first law. So in this lesson, we are going to see in detail about Newton's first law. I have taken up so many examples in the upcoming slides in order to make you to understand very clearly and make you to know the concept. And so in order to make it simpler, please listen to it very carefully and listen as many times as possible till you understand. Therefore, children, so pay much attention to this lesson, because basically it is a very important lesson where the knowledge of this will make you to learn complicated physics in your higher classes. Therefore, we will go into the lessons, please. Yes, children, now first let us see what is force. This term force you have learnt when you were in class 8. So during class 8, when we discussed about force, we have seen a force is nothing but a pull or a push given to an object. Here you can find two pictures. One is describing about the pull and the push, as well as the second also. Now you can see the first boy pushing the box, whereas the second boy pulling the box. So as a result of the pull and push, the box tend to move from one position to other position. So we call this as the motion. Yeah, so a pull or a push given to an object makes the object to displace and hence the box is in motion. Now look at the picture on the right. The person pushes the door. As a result of the push, the door opens inside. And then you can see the next boy, he is pulling a drawer. As he pulls the drawer begins to open. So in all these cases, whether it is a pull or a push, there exerts a force, and that force does some job, either opening or closing or moving from one to another. So simply we can define a force as a pull or a push given to an object. Now let us read the slide. A force can be a push or a pull. For example, when you push a door, it opens, as you have to apply a force to the door. You also have to apply a force to pull or open a drawer. You cannot see a force, but often you can see what it does. Force can change the speed of something, the direction it is moving in, or its shape. For example, an elastic band gets longer if you pull it. So, children, we are going to see what a force can do to an object. Force is an external effort which may move a body at rest or stop a moving body or change the speed of a moving body or change the direction of a moving body or change the shape and size of a body. So let us see one by one. Force can move a body at rest. Now look at the first picture given at the down. You can see a man pushing a car. So this quite often you would have seen on the roads. If the car fails to start automatically, then with the help of some persons nearby, they used to move the car which is stationary. As a result of pushing, the car begins to move from its ideal position. So what you are doing in pushing? You are applying a force on the car. So a force can make the body to move from rest. Second, force can stop a moving body. You can see the next diagram. You can see the goalkeeper of the football game catching the ball to prevent it from goaling. So he stops the ball. The ball is coming at a very high velocity or speed. So he jumps forward to catch the ball. So in doing so, he applies a force and stop the ball from. So the moving ball is being stopped by the goalkeeper. Third one, force can change the speed of a moving body. You can see the next picture. Here is a cyclist. So the cyclist is riding on the bicycle, and you all know that when you want to increase the speed of your bicycle, then you have to apply more muscular force. So as a result, the speed of your bicycle either increases or decreases as you apply the brake. So force can change the speed of the moving object is the example given for this. And then force can change the direction of a moving body. So in the next picture, you can see the batsman in the game of the cricket. He is about to hit the ball. So when the ball is coming in the forward direction, with the help of the bat, he is able to turn the direction of the ball in any direction he wants. So he applies a force in moving the ball or making the ball to move in any direction he desires. So force can change the direction of the moving body. And the last point, force can change the shape and size of a body. On the last picture, you can see the atta, that is what is called flour, wheat flour, being made into chapatis. So you can make any shape out of it, either in the form of a circle or a triangle or in the shape of any of your desire. So this is done simply by applying a force on the wet flour. So force can do all these efforts. So let us revise one by one. Force can move a body at rest. Force can stop a moving body. Force can change the speed of a moving body. Force can change the direction of a moving body, and force can change the shape and size of the body. Children, let us pass on to the types of forces, and we are going to say about balanced force now. The name itself is revealing the forces are balanced. Now look at this diagram in the slide. You find a game called tug of war. Tug of war is a game played between two teams, one on the left and one on the right, pulling a rope on the opposite directions. Children, in this slide, we are going to discuss about unbalanced force. So in the balanced force, we have seen that the forces acting on the object are equal and acting in the opposite direction, as a result of which the net force is zero. And more than that, in the balanced force, the object doesn't displace at all, doesn't move at all. Now here you can see the picture, a man pushing a box. When a man uses a muscular force to push the box, two things can happen. The first thing is the box will not displace or will not move. This is because the muscular force exerted by the man is not overcoming the frictional force between the box and the floor. In the second case, the box may move. The box is moving because the muscular force is greater than the force of friction exerted between the box and the floor. So in the second case, the box moves because the muscular force is greater than the frictional force. So here it is an unbalanced force. So the force of the muscular force is greater than the frictional force. Therefore, the force, one of the force is greater, and so the box moves in the direction of the greater force. So here it is said to be unbalanced force. Always there will be a displacement in the unbalanced force. Now let us look at the slide. If the resultant total of all the forces acting on an object is not zero, it is called unbalanced force. Example, force required to move stationary object. Suppose a heavy box is kept on the ground, we try to push it with our hands. In this case, if we push it with less force, it does not move, as our muscular force exerted by the body is balanced by the force of friction. However, if we push it with more force than frictional force, it moves because the force now is unbalanced force. As muscular force exerted by our body is more than opposing force of friction. Now we can see the second figure. It represents a ball moving from left to right. When the ball rolls on the ground from left to right, then there exists a force of friction between the ball and the ground in the opposite direction. You might have learnt in the lesson friction last year, and therefore the force of friction always opposes the force of motion. So what happens? The ball, after moving a certain distance, it stops. So it stops because of the frictional force exerted between the ball and the ground. Now see to the slide. Force required to stop moving object. A moving ball stops by itself after some time. It is because the force of friction exerts opposite force on the object. This force of friction is more than the force of the direction of the ball in which it moves. So let us see about the balanced and unbalanced force on a single slide now. Balanced force, when two or more forces acting on an object are equal in all directions, it is said to be balanced force. So it results in no movement. So you can see in the picture down, a force of 300 Newton is applied on the rope to the left, and the same 300 Newton force is applied onto the right. Therefore, there will not be any moment. The resultant force is 300 minus 300. It will be 0 newtons. Unbalanced force. When two or more unequal forces act on an object, then moves in the direction with more force. Then net force is the difference between these forces. So here you can see in the following diagram, the team on the left, they exert 400 Newton force, and the team on the right, they exert 300 Newtons on the opposite direction. Since the team on the left, they exert more force, then they try to attract or they try to pull the other team towards them. Therefore, the rope will move towards the 400 Newton force. And what is the resultant of this force? So 400 minus 300, it will be 100 newtons towards the left side. That is the resultant of the unbalanced force acting here. This slide gives more clearly about the balanced and the unbalanced force in detail. First, balanced force. If two forces act on a body in opposite direction, and if both the forces are equal, then the resultant forces acting on the body is zero. Such forces are called balanced force. Balanced force cannot change the state of rest or motion of a body. Here you can see the left side force as F1 and the right side force as F2. Both the forces are equal. F1 is equal to F2. It can be 10 newtons on the left and 10 newtons on the right side. Any equal values of force, you can take it up. Then unbalanced force. If two forces act on a body in opposite direction, and if one force is greater than the other, then the resultant force is not equal to zero. Such forces are called unbalanced forces. Unbalanced forces changes the state of rest or motion of the body. Here F1 acts on the left side, F2 acts on the other side. F1 being greater than F2, the object moves towards the left side. So always unbalanced force makes the acceleration in the body. Now let us see about the differences between balanced force and unbalanced force. First point, if resultant total of all the forces acting on an object is zero, it is called balanced force. Unbalanced force. If the resultant total of forces acting on an object is not zero, it is called unbalanced force. Example, force present in stationary object. Force required to move stationary object. Then force present in objects moving with constant velocity. Force required to stop moving object. Tug of war game, both teams exert equal force. Tug of war game, both teams exert equal forces. This force cannot move stationary object. This force can move stationary objects. This force cannot stop moving object. this force can stop the moving object. So these are the major differences between balanced and unbalanced force. And at the top it is given the net force for a balanced force is 0 and there will not be any acceleration. At the same time, the net force causes acceleration and because of the unbalanced force. Children, let us discuss about the frictional force acting on an object. The force of friction. Force of friction is the force which opposes the motion of an object over a surface. Example, a ball rolling on a ground gradually slows down and comes to a stop due to force of friction. If we stop pedaling a bicycle, it gradually slows down and comes to a stop due to force of friction. In the following diagrams or the pictures, we can see about these effects of friction on the body. Let us take the first picture. We can see that the body is moving from left to right and at the same time the force of friction is from right to left. So we see that the frictional force is always acting on the opposite direction to the direction of movement of the body. Since it is the opposing force, it tries to stop the moving object. Now the ball, as he rolls on the grass, after going a distance, it tries to stop because of the frictional force. And the cyclist, when he stops pedaling, the cycle comes to a rest after some time due to the frictional force between the bicycle tires and the road. So a frictional force is the force which tries to stop the moving object. Now let us see the down. An object with uniform motion will continue to move with uniform motion if the forces acting on it, that is the pushing force and the frictional force, are balanced. So if the forces are balanced, then the object will continue to move with uniform motion. On the other hand, what will happen if an unbalanced force acts on the moving body? Then its speed or direction of motion changes. If the unbalanced force is removed, then it will continue to move with the speed it had acquired till then. Children, we will see about the Galileo's experiment of motion of an object on an inclined plane. Now you see in the picture, a ball is being rolled on an inclined plane from the left, and you have three types of inclined plane onto the right. Number 1, number 2 and number 3. The number 1 is equally inclined as that of the left. When you take plane number 2, it is not equally inclined and it is inclined at a greater angle. And third one, it is not at all inclined, it is horizontal. So let us roll a ball from the left and see what happens to the ball for all the three cases which we had discussed now. When a marble or a ball rolls down an inclined plane, its velocity increases, and when it goes up on the second inclined plane, its velocity decreases. If the inclinations of both the planes are equal, then the marble will reach the same height which rolled down. That is the case number 1. So the ball or the marble, when it is inclined from the left, and if the inclinations are one and the same angle, then it will reach the same height. Second case, if the inclination of the second plane is increased, it will travel more distance to reach the original height. So the distance traveled by the ball when the inclination is more will be more than that of the first. But at the same time, now also it will reach the same height. Then third case, if the inclination of the second plane is made horizontal, the marble will travel forever trying to reach the same height. So in the third case, the inclination is almost horizontal, so it will travel more distance. Therefore, what is the result of this experiment? An unbalanced force is required to change the motion of the marble, but no force is needed to sustain the ununiform motion of the marble. Based on the all concepts which we have learned earlier, a new word, inertia, is being now introduced. What is inertia? The property of an object that resists changes in its motion. Of an object at rest tends to stay at rest. An object in motion tends to keep moving at a constant speed in a straight line is known as inertia. So in the example of a rolling ball, we had seen that the ball comes to a stop because of the external forces acting on the object, such as the force of friction and the force of gravity. If these forces are being removed, then the moving ball will move continuously with the same velocity or speed. So this is the property of inertia in motion. And you all know that when a body is at rest, it will be at rest forever, provided no external force acts on the body. If you keep a book on your table, and when you come back after a week or an even a year, the book will be in the same place because it is not disturbed by the external force. So the property of a body at rest to be at rest forever, and the property of a body which moves will be in motion forever is said to be called as inertia. Now let us discuss about inertia of rest in detail. Inertia of rest can be defined as the inability of an object or body to change its state of rest by itself. For example, when a car is suddenly started, the passengers in it fall backward. Ever wondered why that happens? Well, the lower part, which is in contact with the car, comes in motion, whereas the upper part remains in rest due to inertia of rest. So, the inability of a body to change its state of rest by itself is known as inertia of rest. So when we are sitting in the bus, when the driver starts the bus, we tend to move ourselves backward. This is because of inertia at rest. And you see the second example with the picture. You can see an apple tree and you can see a machine which is fitted to the trunk of the tree, and the machine gives the tree a vibratory motion. When the trunks are vibrated, then all the apples which are on the branches of the tree begin to fall down. So this is based on Newton's first law. Now that is inertia. Inertia at rest. Have you ever wondered why the fruits or the leaves fall down when the branches of a tree are shaken? It's due to the inertia of rest. Before shaking, the branches is at rest. But when the tree is shaken, the branches starts moving, whereas the fruits and the leaves remain in their initial state of rest. That is, thus they fall down. We will now discuss about inertia of motion. Inertia of motion can be defined as the inability of an object or body to change its state of motion by itself. For example, if we reverse the first example, we will understand the inertia of motion. Let us say that you are in a moving car, and when it suddenly stops, all the passengers fall forward. That is because the lower part of the body, which is in contact with the car, is at rest, whereas the upper part tends to remain in motion due to inertia of motion. So when the brakes are being applied, we tend to fall forward. This is a very good example to explain inertia of motion. Now you see the picture here. There is a big carpet, and this big carpet is being dusted. How they are removing the dust from the carpet, we'll see to it. Do you know what makes the dust particles fall off the carpet? It is all due to the magic of inertia. When you beat the carpet with a stick, the carpet starts moving, but the dust particles in it remain in their initial state of inertia of rest. The repeated beating of the carpet causes the dust particles to drop, thus giving you a clean carpet. So the carpet is being dusted with the property of inertia at rest. This slide gives the inertia of direction. Inertia of direction can be defined as the inability of any physical object to change its direction of motion by itself. For example, when a car moves along a round curve, the passengers sitting inside are thrown outwards. This happens due to the inertia of direction in order to maintain the direction of motion. Driving along a curved road is a very perfect example of inertia of direction. While driving along a curved road, you must have felt like you are flying out of the car. It's because of the inertia of direction, which tends to keep your motion in a straight line. This slide gives you more examples on the day-to-day events, which is based on inertia of rest and inertia of motion. The first one, why do we wear car seat belts? Car seat belts are there to keep you safe during an accident. It acts as an external force to keep your body intact when your vehicle collides with any external object. In this case, the upper part of your body, which is in the state of motion, tries to move forward due to inertia of motion, but the seat belt comes into your rescue and cancels the effect of inertia. Secondly, you must have seen athletes running before taking a long jump, but have you ever pondered on why they do so? Well, they do it to bring themselves in the inertia of motion from the inertia of rest. It makes it easier for them to take a long jump. Isn't it fascinating? Have you ever tried getting down from a moving bus? Well, if you have, then you must know the result, but did you ever wonder why you fall forward and not backward? This is again due to the inertia of motion. When a passenger gets down from a moving bus, their upper body is still in motion, and when it comes to contact with the ground, which is at rest, their body topples forward due to inertia of motion. This slide gives a very good example where you can perform it by yourself, the property called inertia at rest. See to the experiment. You have a glass. The glass is covered with a cardboard and a coin is kept on the cardboard. The aim of this activity is to drop the coin into the glass without touching it. How can you make the coin to fall into the glass tumbler without touching it? So you see to the next part of it. What does he do? When the cardboard is flicked, the coin falls into the glass. This is because the inertia of the coin maintain its state of rest and it falls into the glass due to gravity. So what you need to do is you have to flick the cardboard with a very high force. When you flick the cardboard just grabs and falls to a greater distance and the coin begins to fall into the glass because the coin maintains the state of rest. It's a very good example where you can demonstrate by yourself to know about inertia at rest. Here is another experiment where you can do it by yourself about the same property, inertia of at rest. Describe in brief an activity to illustrate the property of inertia of rest. Make a pile of similar carom coins on a table or on a carom board as shown in the figure. If we hit it strong enough, the bottom coin moves out quickly. Once the lower coin is removed, the inertia of the other coins makes them fall vertically on the table. So if using a striker, if you hit hard the lowermost coin, then the lowermost coin alone is removed from the pile of coins where the other coins remain as the pile of coins as itself. But if you hit it with less force, then the pile of coin collapses its position and falls off. So this is a very good example to explain about the property of inertia at rest. Children, this slide gives various examples to illustrate the property of inertia. When a hanging carpet is beaten with a stick, the dust particles starts coming out of it. When a carpet is beaten by stick, the carpet is set into motion, but due to inertia, the dust particles remain at rest. Thus, they get separated from the carpet. Second example, on shaking or giving jerks to the branches of a tree, the fruits fall down. When the branches are shaken in one direction, the fruits and leaves, due to inertia, remain at the original position due to inertia of rest. This causes breakup of the stalk and they fall down. When a bullet is fired at a glass window, a hole is formed in it. This is because only that part of the glass moves with the bullet, where the bullet hits the glass. The remaining part, due to inertia, remains in its position. Thus, bullet is able to form a hole in the glass window due to inertia of the window pane. A magician snatches a tablecloth from under a full set of tableware. When the tablecloth is pulled, it is set into motion, but the tableware, due to inertia of rest, remains on the table. When the local train starts or stops suddenly, sliding doors of some compartments may open or close. Now, let us discuss some more examples for inertia of motion. When a stationary bus starts moving, passengers in the bus get reclined back simultaneously when the bus moves with uniform velocity, stops suddenly, passengers move forward. So these two things are happening due to inertia of motion. What is the explanation? When the bus is stationary, the passengers are also stationary. When the bus starts moving, the part of the body, lower part, which is in contact with the bus starts moving. But due to inertia, the upper part remains stationary and thus he gets reclined back. If he is standing, he will fall backward. When the bus is moving with uniform motion in a straight line, the passengers have the same motion. When the bus stops, the part of the body, lower part, which is in contact with the bus stops. But due to inertia, the upper part continues to move forward and thus he moves forward. If he is standing, he will fall forward. This is a very, very important question for the examination point of view for the property. Here are some more examples given on the same concept. When a passenger jumps out of a moving train, he falls down. This is because as soon as the passenger leaves the running train, his velocity is the same as that of the train. When his feet comes in contact with the ground, the lower part of the body is brought to rest, but the upper part of the body continues to travel with original velocity. This makes him fall in forward direction. To avoid this, he has to run in the forward direction till his velocity is reduced to zero. Second point, a ball thrown vertically upward by a person in a moving train comes back to his hand. The reason is that the moment the ball was thrown, the ball was in motion along with the persons and the train due to inertia of motion. So, during the time the ball remains in air, both the person and the ball move ahead by the same distance. This makes the ball come back to his hand on its return. Athletes run before taking a long jump in order to increase his speed and thereby his inertia of motion. The increased inertia of motion enables him to jump a longer distance. Athletes for long jump, javelin throw, shot puts, etc. often fail to stop themselves before fault line because of the inertia of motion. The upper part of the athlete body continues to move in the forward direction while the lower part comes to a halt. Thus, he may not be able to stop at the fault line and cross it. In all the slides above, we have seen about inertia. Now, let us interlink inertia with the mass of an object. A body at rest continues to be at rest, and a body in motion continues to be in motion. This property of a body is called its inertia. The inertia of a body is measured by the magnitude of force required to change the state of the body. The force is required to change the state of a heavier body is more than the force required to change the state of lighter body. If the body is lighter, the force required to move it is also light. When the body is heavier, then the force required to move is more. This is because mass of the heavier body is more than the mass of the lighter body. So, the mass of a body is a measure of its inertia. Greater the mass, greater is the inertia. Or in other words, mass and inertia are directly proportional. At last, now we have come to the slide which is explaining the Newton's first law of motion. Newton's first law of motion states that an object remains in the state of rest or in uniform motion in a straight line unless compelled to change that state by an unapplied force. So this is the statement of Newton's first law of motion. This statement is a very important statement and it contains the two inertias, inertias at rest and inertia in motion. If a body is at rest, it will be at rest forever. If a body is in motion, it will be in motion forever, provided no external force acts on the body. This is the simple concept of Newton's first law. Children, by this we come to the end of today's learning session, and today we had taken up about the force, what a force can do, the effects of force, and then we have introduced the new term called inertia and the type of inertia, and at last we have come to the statement of Newton's first law of motion. So various examples are being given here and there, and these examples are very important as far as the examination point of view. Therefore, I request you to go through the slides until you get understand many number of times and get understand the concepts clearly, children. So there will be a viva, that means whether you have learnt the concept properly or not. I will test by ringing you up. Therefore, after you go through the slides, just post in the group that you have watched the videos. So during my free time, I will call you for the viva. Okay, children, get ready.